Hello students, in this video we will discuss about the previous year NEET chemistry questions. Let us move on to the first question.
The correct statement regarding a carbonyl compound with a hydrogen atom on its alpha carbon is. So the correct answer is option 3. A carbonyl compound with a hydrogen atom on its alpha carbon rapidly equilibrates with its corresponding enol, and this process as ketoenol tautomerism. I will show you an example, the ketoenol tautomerism. For here we take a ketone form or C double bond O CH2 or dash. Here this is a ketone which undergo tautomerism and form enol. So the interconversion of two forms, that is keto and enol, involves the movement of alpha hydrogen and the shifting of bonding of electrons. So a carbonyl compound with a hydrogen atom on its alpha carbon rapidly equilibrates with its corresponding enol, and this process is known as ketoenol tautomerism. So the correct statement is option 3. Next, move on to the second question. The pair of electron in the given carbanion is present in which orbitals? So first we write down the carbanion CH3 C triple bond C. Here the anion, that is the lone pair of electron, which is obtained from CH3 C triple bond CH. Here when loss of acidic proton takes place, this carbanion is formed. Here the pair of electron, that is this pair of electron in the carbanion present at C triple bond C carbon. This carbon has one single bond, two pi bond and one lone pair of electron. So thus it is sp hybridized. The pair of electron in the given carbanion is present in sp orbital. So the correct answer is option 3. Next, move on to the third question. Which of the following biphenyl is optically active? So the structure of biphenyl compound is like this. So the biphenyl compound which will not have a plane of symmetry will be optically active. Due to steric hindrance caused by the ortho substituents, these positions are ortho. The two rings will not be planar and will not have a plane of symmetry and will be optically active. Now let us discuss each compound in the question and check if they are optically active or not. So first come to the second option. The compound given to us has a center of symmetry. Center of symmetry, which means on moving equal distances from the center on towards the opposite sides, we will land on the symmetrical structure. So this is optically inactive. Improper substitution. So next come to the third option. Here the compound given to us, both the substitution is on the same ring. So this will cause ortho effect, even though they are not planar, still it is optically inactive as it has a center of symmetry. So, due to improper substitution, this is optically inactive. So, next come to the option 4. There is ortho no ortho substitution. So, improper substitution. So, thus there are in the same plane and it is optically inactive. So, option 4 is optically inactive compound. So, next come to the first option. Due to the steric hindrance of bulky orthosubstituents, the rings are not planar. So, thus it does not have a plane of symmetry. So, it is optically active. Due to the steric hindrance of the bulkiest of the orthosubstituents, the rings are not in planar. So, the option 1 is optically active compound. So, the correct answer is option 1. Next, move on to the fourth question. In which of the following molecules all atoms are coplanar? So, the molecules in which all the carbon atoms are sp2 hybridized will be coplanar. So, here we can see in the option 1. So, this biphenyl compound given to us is coplanar. In this, the carbon atoms are in sp2 hybridized state. So, here all the carbon atoms are in sp2 hybridization. Hence, this molecule is coplanar. So, option A is a right answer. Next, move on to the next. In pyrrole, the electron density is maximum on. So, they ask the maximum electron density position of pyrrole molecule. So, pyrrole is a 5-membered heterocyclic compound. The electron density on the carbon atom is dependent on the movement of the non-bonding electrons of nitrogen inside the ring. So, here I write down the conjugation of electrons in pyrrole. So, first here in pyrrole molecule, here the lone pair of atoms. So, first we write down the number for all the positions. Here the lone pair of electron is shift over here and the this electron come to third position. So now we write down the structure as H. So here nitrogen becomes positive charge and third position becomes negative charge. Now this negative charge is shift over here and this double bond is shift over here. So we can get like this. So positive charge is remaining in nitrogen and the negative charge comes over fifth position. Now the shifting of negative charge takes over here and the molecule like this. So again this negative charge shift over here and the bond comes over here. So this is fourth. Finally we get like this. So all the five structures are termed as the resonating structures of pyrrole. The resonating structures indicate that the nitrogen carries positive charge and the 4 carbon atoms carries negative charge. That is, nitrogen carries a positive charge and all the carbon atoms carries negative charge. Of the 5 resonating structures, the charge separation is less in third and fourth. So here we see here in structures third and fourth, the charge separation is less. However, the charge separation is more in second and fifth. So this results more stability to structure third and fourth. Thus, the maximum electron density will be found on carbon, the structures 2 and 5. So, the correct answer is 2 and 5. That is option number 4. Next, move on to the sixth question. The order of stability of the following tautomeric compound is. So, here they give 3 structures to us. The tautomer 3 has higher stability. Here the C double bond C and C double bond O are conjugated with results in delocalization and hydrogen bonding. The tautomers 1, which is less stable than 2. Here the enol is less stable than carbonyl group. Thus the order of stability comes as, so the more stability comes for third structure, and compared to 1 and 2 the stability is more for second structure, because the first structure is less stable than the tautomer. Second, here the enol is less stable than carbonyl group. So the order of stability of the following tautomeric compound is 3, 2, 1. So the correct option is 2. Next, move on to the 7th question. The structure of isobutyl group in an organic compound is. So, by removing a hydrogen from a primary carbon atom of isobutane gives a primary alkyl group which is called as isobutyl group. The isobutyl group is having 2 methyl groups and 1 hydrogen bond. So, we write the structure of isobutyl group like this. So, the structure of the isobutyl group in the organic compound is represented by option A. When a second carbon of the chain has a methyl group attached to it, it is called iso group. Here, methyl, that YL suffix is used to 1 hydrogen which is less than the parent hydrocarbon. So The correct structure of isobutyl group in an organic compound is option number, which is given in option number 1. Next, we will move on to the 8th question. The correct statement regarding the comparison of staggered and eclipsed conformations of ethane is. So there are 4 options are given to us. Let us see the correct option. So first we think about what is conformation of ethane. So ethane molecule contains C2H6. So here CC single bond, each carbon attached with 3 hydrogen atoms. So here we kept first carbon as a stationary and second carbon as a rotate. So this rotation results in infinite number of spatial arrangements of hydrogen atom attached to one carbon atom with respect to the hydrogen atoms attached to another one. So in this case we get 2 extreme conformations. So here we one is eclipsed conformation, another one is staggered conformation. In eclipsed conformation, here the hydrogen atom attached to 2 carbon atoms are closed together. So these 2 hydrogens are closed together. So this type is called eclipsed conformation. So in another one, that is staggered conformation, would be like this. So here the staggered conformation of ethane is more stable than eclipsed conformation due to the torsional strain. Here torsional strain is very less compared to eclipsed conformation. In staggered conformation, there are even spaces between each atoms which minimized. So since eclipsed conformation has a greater potential energy due to the torsional strain, so here eclipsed conformation is less stable than staggered conformation. So here in staggered conformation, no torsional strain is there. Here due to torsional strain, eclipsed conformation is less stable. So the correct option is option number 3. That is, the eclipsed conformation of ethane is more stable than staggered conformation because staggered conformation has no torsional strain. Move on to the 9th question. In the reaction, acetylene which undergo reaction in presence of NaNH2 with liquid ammonia, and it undergoes alkylation and it produces X, which again reacts with the same reactant and it gives Y. So they asking us X and Y are. So first acetylene which reacts with
NaNH2 liquid ammonia, which gives acetylide anion. Here triple bond, acetylide, anion. So which further undergoes alkylation with ethyl bromine. It gives 1-butane. See, CH2, CH3 plus hydrogen bromide, 1-butane. This is product X. So next, further it reacts with NaNH2 in presence of liquid ammonia. Again it forms an anion. So C minus, triple bond C, CH2, CH3. So again it undergoes alkylation with CH3, CH2, where which yields CH3, CH2, C, triple bond C, CH2, CH3 plus hydrogen bromide. So the product is 3-hexene. So this comes as a Y. So X and Y are 1-butane and 3-hexene. So the correct answer is 1-butane and 3-hexene. The correct option is number 4. So let us move on to the 10th question. So here in the given reaction they give 2 reactant which reacts in presence of hydrogen fluoride at 0° centigrade. So we need to find out the product P. So first, this reaction is an example of Friedel-Crafts alkylation reaction. So, and this is an example for electrophilic aromatic substitution reaction. So in this reaction pi electrons of this is benzene, this is cyclohexene. So in this reaction the pi electrons of cyclohexene reacts with hydrogen fluoride, forms a carbocation. So it further this carbocation reacts with benzene ring which undergo electrophilic substitution reaction and forms a final product So the correct option is option 3. So next, move on to the 11th question. 2,3 dimethyl 2-butane can be prepared by heating which of the following compounds with a strong acid? So in presence of strong acid, rearrangement reaction takes place. Rearrangement reaction occurs. So in first step, H plus is added to the compound. So first step, H plus is added. So here we take option 2, that is H33 C single bond CH double bond CH2. So while heating in presence of strong acid, here the H plus is added to this carbon. So we write down this as CH3 CH plus CH3. So in this second step, a methyl group migration takes place. So after migration of methyl group, we get here one of the methyl group shift over here CH3 C here twice. So this carbon becomes positive and the methyl group shift over here. So CH3 hydrogen CH3. So in the third step, removal of proton takes place. So proton is removed. So CH3 twice C here double bond C CH3 the whole twice. So the correct option is option number 2,3 dimethyl 2-butane can be prepared by heating of this first given compound. So option number 1 is the correct answer. So move on to the next question. Which of the following compounds shall not produce propene by reaction with hydrogen bromide followed by elimination or direct only elimination reaction? So here first we take this cyclopropane which undergoes reaction with hydrogen bromide, that is electrophilic addition reaction, which gives CH3 CH2 bromide, further undergoes elimination reaction of HBr. It produces, so here this hydrogen will remove and this bond carry out here. So the final product is CH3 CH double bond CH2, that is propene. So next, so the cyclopropane produces a propene as a product. So next we come to the propanol, which undergo electrophilic addition reaction. So here removal of water molecule takes place and we get CH3 CH2 CH2. Here further elimination takes place and we get CH3 CH double bond CH2. So the propene is the product of propanol. So next come to the third option. So here the given compound reacts with hydrogen bromide. Here nucleophilic addition reaction takes place. So nucleophilic addition takes place and we get CH2 double bond C B bromine, here OH. So it gives a tautomeric form, that is CH3 C double bond O here. So for third compound the yield is not a propene compound. So come to the fourth option. So it undergo reaction with hydrogen bromide. So it directly gives CH3 CH double bond CH2. So that is propene compound. So the correct answer is option 3. So the compound which shall not produce propene by reaction with hydrogen bromide followed by elimination reaction. So the correct option is option number 3. So next move on to the 13th question. The compound that will react most readily with gaseous bromine has the formula. So they ask the compound which will readily react with gaseous bromine. They ask the formula. So here the given formula are C3H6, which is propane. So this one is ethylene. So option 3 is butane. Option 4 is ethene. So as we know, bromine reacts with unsaturated compound. So possibility of option 3 is omitted now. So bromine which only reacts with unsaturated compound. So here the clue is given in question here, which is bromine is taken in gaseous state. So as we know, normally bromine exists in liquid state. So but if it is present in gaseous state, that is possible only upon a heating process. So bromine is in gaseous state. So in gaseous state, bromine reacts only with allylic. So allylic of those alkenes which have a allylic hydrogen atom. So the gaseous bromine only reacts with those remaining alkenes which have a allylic hydrogen atom. So here we take CH3, CH double bond, CH2. So in the given option, the fourth option, so in the given four option, this propane is this first option. The propane is having allylic hydrogen. At high temperature, bromine will form bromine free radical, and for that allylic substitution will takes place. So we get CH2Br, that is bromine, CH double bond CH2. So allylic hydrogen is not present in ethene, so this cannot be the answer. So the correct answer is option number 4. So for the reaction of gaseous bromine, the compound which must have allylic hydrogen atom. So the correct option is option number 1, that is propene. So next come to the 14th question. Which of the following compounds will not undergo Friedel-Crafts reaction easily? So here we have given 4 options. In this, nitrobenzene does not undergo Friedel-Crafts reaction because the nitro group, this nitro group of the nitrobenzene is strongly electron withdrawing group and deactivates the ring, so that the electrophile cannot attack on benzene ring easily due to deactivation of benzene ring. So nitrobenzene becomes incapable to give Friedel-Crafts reaction. So the correct answer is option 3. Move on to the next question. Some meta-directing substituents in aromatic substitution are given. Which one is most deactivating? So some of the aromatic substituents are given to us. These are some meta-directing aromatic substituents. Which one is, we want to find which one is deactivating. So mainly deactivating effect is mainly due to inductive effect and resonance effect. So among all the 4 options, hence nitro, Cn and SO3H are strongly deactivating groups, but this COO acidic group is moderately deactivating group. So compared to the 3 nitro, Cn and SO3H, nitro group is most strongly deactivating group. So the correct answer is option number 4. So the nitro group is most reactivity group.
Let us see the next question. The heating of phenyl methyl ethers with HI produces. Here the phenyl methyl ether is nothing but anisole. So benzene ring, here ether group which is attached with methyl group. So phenyl methyl ether is a anisole. So this problem is based on resonance stabilization. In anisole, the methyl phenyl oxonium is formed by protonation of ether. So when anisole reacts with HI, it produces methyl phenyl oxonium ion. So here the protonation of ether takes place, and here the lone pair of electrons here. So here O, CH3, here H. So this is methyl phenyl oxonium ion, which further undergoes reaction with iodine, form phenol and alkyl halide, which is nothing but methyl iodide. This one is phenol. So the bond between OCH3 is weaker than the bond between OC6H5. So because the carbon of phenyl group is sp2 hybridized and there is a partial double bond character, thus the reaction yields phenol and methyl iodide, that is alkyl halide. So the correct answer, when the heating of phenyl methyl ethers with HI produces phenol. So the correct answer is option 3. Next, move on to the 17th question. For the following reactions, which of the following statement is correct? So here 3 reactions are given to us. First, let us see the first reaction, that is CH3CH2CH2Br, which is reacted with potassium hydroxide, produces propene. So it undergoes, here we see this first reaction undergoes elimination reaction. So here in first reaction CH3CH2CH2Br plus potassium hydroxide, here removal of potassium bromide takes place and forms CH3CH double bond CH2 plus potassium bromide and water molecule. So it comes under elimination reaction. So the first reaction is elimination reaction. Come to the next reaction. So here the reaction takes place is substitution reaction. So here we see this compound, when reaction with potassium hydroxide, it produces CH3 here OH. So and removal of potassium bromide takes place. Here the hydroxyl group can be substituted in the bromine position. So this comes under substitution reaction. So the second reaction is substitution reaction. So next come to the third reaction. Here hexene which reacts with bromine, it gives dibromo so here hexene reacts with bromine gives dibromobenzene. So here two bromines are attached in the benzene ring, so it produces, so here addition takes place. So addition of bromine takes place, so this comes under addition reaction. So third reaction comes to addition reaction. So the given first reaction comes under elimination reaction, second reaction comes under substitution reaction, third reaction comes under addition reaction. So the first reaction comes under elimination reaction, second reaction comes under substitution reaction, third reaction comes under addition reaction. So the given question is, for the following reactions which of the following statement is correct? So the correct answer is option 1. Move on to the next question. The reaction, so the given a particular reaction which can be classified as, so here they given the options are all alcohol formation reaction, dehydration reaction, Williamson alcohol synthesis reaction, Williamson ether synthesis reaction. So the formation of here the product is, the forming product is ether. So the initial reactant alcohol, here alcohol in presence of base, so sodium hydroxide is a base. So here we can see the formation of ether takes place by reacting alcohol in the presence of base, which followed by alkylation is known as Williamson ether synthesis reaction. Here we see here the alcohol, this is alcohol which reacts with sodium hydride as a base. Further it undergoes alkylation with methyl iodide, forming a ether molecule. So this reaction is known as Williamson ether synthesis reaction. So the correct option is 4. Move on to the next question. Which of the following reagents would distinguish cis-cyclopenta 1,2 diol from the trans isomer? So this cis-cyclopenta 1,2 diol. So the cis form of cyclopenta 1,2 diol
when reacts with acetone, so when reacts with acetone forms cyclic ketol, so forms a cyclic compound, forms a cyclic compound, that is cyclic ketol. But whereas trans isomer of cyclopenta 1,2 diol, so here, so in trans isomer in trans cyclopenta 1,2 diol, which this is first one is cis form, this is trans form, reacts with acetone, there is no reaction takes place, that is this trans form of cyclopenta 1,2 diol doesn't form a cyclic ketol. So the correct option is option number 4, that is acetone. So the cis form of cyclopenta 1,2 diol reacts with acetone to form a cyclic ketol, but while during reaction with trans form of cyclopenta 1,2 diol there is no reaction takes place. So next move on to the 20th question. Which of the following can be used as the halide component for Friedel-Crafts reaction? So here they given 4 halide components, that are not chlorobenzene, bromobenzene, chloroethane, isopropyl chloride. In chlorobenzene, bromobenzene and chloroethane, the lone pair of halogen is delocalized with pi bonds, that is here, which is like this, double bond, so here we see in chlorobromobenzene along with chloroethane have carbon halogen bond as, so that is lone pair of halogen is delocalized with pi bonds, so it attains double bond character. Thus these are not suitable as halide component for Friedel-Crafts reaction. So the option isopropyl chloride, which is a suitable halide component for Friedel-Crafts reaction. Here I will show the Friedel-Crafts reaction which takes place with isopropyl chloride. So here first the benzene which reacts with isopropyl chloride, so in presence of anhydrous aluminum chloride produces the product. So only the isopropyl chloride is used as a halide component for Friedel-Crafts reaction. So the correct answer is isopropyl chloride. Thank you.